So I've got a problem with the toy car that drives itself off a table. It has a velocity in the x direction, but we don't know what that value is. And we need to determine several things. First thing, let's talk about the problem. I'm given the information of how high the table is. I'm given the information of where the car lands. And from that bit of information, from those two pieces of information, I have to solve for how long it takes for the car to drop to the ground and how fast it's going in order for that car to hit the distance away from the tabletop. Okay? So the first thing I always do when doing a two-dimensional problem is I always draw a picture. And the reason why I draw a picture is so I can keep track of it. Make sure that I'm taking the information that I'm given and putting it in the proper place. The first thing is the height of the table. So I'm talking about from here to here. That's 1.255 meters. Okay? So I can see that this height is going to be in my y-axis. Okay? I'm also given how far away from the table the car crashes. So here's my car. Here's the remote control. And it's going to go point. So I need to know, or I do know, that this distance is 0.4 meters. Okay? Cool? So from there, I need to be able to solve those problems. The next step I always do when dealing with any of these kinematic problems is I come up with a table. And for two-dimensional motion, that table is going to be my x and my y information. X, y. So my acceleration, my initial velocity, my final velocity, my initial position, my final position, and lastly, time, which doesn't really go on the table because time is not a vector. Okay? So from that, I want to start filling out my charts. The first thing I want to do is talk about acceleration. So as the car falls off the table, it's being pulled. Okay? The only direction it's being pulled is it's being pulled down by the force of gravity. Okay? So that gives it an acceleration. And that acceleration is about 10 meters per second. We know for a fact that it's actually 9.8 meters per second, but 10 is close enough. It makes the math simpler. Okay? Now, is it being pulled in the x direction? The answer is no. So there's no pull there. So no acceleration. Okay? Talking about initial velocity. Initial velocity in the x and initial velocity in the y. I've given initial velocity in the y. As a matter of fact, that's one of the things I need to solve. So put an x because I need to solve that. Okay? Now how about in the y direction? Well, all the motion of the car is in this direction as it goes off the table. So there's no downward component of that velocity initially. Okay? Now how about velocity final in the x? Well, it turns out that these two are equal to, because there's no acceleration, the final velocity and the initial velocity are going to be equal to each other. How about in the x direction, or in the y direction? It does change, but I don't know how much. But it's not something I'm looking for, so I'm going to put a question mark. Now, initial position in the x, I can say that that's 0, and its final position is 0.4. And then now talking about the final position, or the initial position in the y, I have two options. I can say that it starts at 0 and goes down to a negative 1.255, or I can say it starts at 1.255 and goes down to 0. It turns out it doesn't really matter which one of those two I use, I get the same results. So what I'm going to do is I'm going to say that this is 1.255 So now that I've filled out my chart, I'm going to try to solve some of these problems. Now, I'm going to have to erase the picture, but you guys have it in the video, so I'm not worried. Oh, where's my towel? This one. Okay? So, talking about in the y direction. In y, the y direction, I have most of my information. Okay? I still don't know what time is. I still don't know what final velocity is, but for the most part, I have more information in my y than I do in my x. Okay? Give me 1 second. That helped. Okay, so x is equal to, well, x final equals x initial plus v initial t is 1/2 a t squared. Position equals initial position plus initial velocity times time plus 1/2 the acceleration times time squared. Cool? I said my initial position in the y, or my final position in my y is 0. My initial position is 155 meters plus, now the initial velocity is 0, so 0 times t is still going to give me 0. I'm going to leave that term out of there. It's not that important this time. Plus 1/2 negative 10 t squared. Well, don't forget my units. Meters per second, second. T squared. Okay? I'm going to move this term over, and then I'm going to multiply this 1/2 to this negative 10. So I'm left with negative 1.255 meters is equal to negative 5 meters per second t squared. I bring this term over to that side. I'm left with negative 1.255 by negative 5 meters per second equals t squared. Okay? Now, if you look at it, the meters cancel off, and I have a 1 over second squared basically. Okay? So 1 over a 1 over second squared is going to give me second squared, and time squared. That seems to jive. Now, talking about the division here, I have 2, 5, 1. Okay? 1 decimal point. So I end up with an answer of 0.251 equals t squared. Okay? Or 0.5 approximately equals t. So I'm left with 0.5 equals t. Cool? So I'm going to go ahead and record that over here. So I've got one of my responses. I've got that 0.5 is equal to, and I put my seconds in there. 0.5 seconds is equal to t. Cool? I'm going to do the second half in the next video.